with authentication with the cluster. And the next chapter is next week is RBAC, policies and auditing. I think these two are like areas that people like maybe get into the weeds on this once they start like working in an enterprise with Kubernetes versus just taking the certification tests when they get into an environment that they have to understand these things. Having a book and experts that have this information is super useful. And also, if you're not familiar with the book also has a GitHub repo with all the shell scripts and all the YAML files and the instructions from the group. The book has the sections of the commands that you have to run, and the book authors were very good at, I think that's my feedback, on not splatting all this configuration and YAML into the book and then putting some like commands, like shell scripts, like run this script and it will set up this piece, and then a little bit of more commands, but it doesn't have all the configuration splatter everywhere like other books that we've seen. So I think that's, I don't know if I gave that feedback before, but that's feedback for the book. I don't know if that was intentional or not intentional.
Carlos, in the first two editions, we had a little bit more of the code in the book, and we decided there were reasons for that. All right, this way, if you'd use it as a reference guide, you had it. But we really needed the extra space, to be honest, for all the stuff we wanted to add. So we pulled most of that out, and we documented the scripts a little bit more inside the scripts themselves. This way, you still have reference to them. So great feedback on that. We appreciate that, because Mark and I honestly weren't sure how that would go. Right? People might not like that. People might. Seems to be very well received. Right? You don't need the book for the code. That's what the GitHub's for.
Yeah. And I think you're maintaining the GitHub. I think it's in the agenda docs at the bottom, but yeah, it is available. So Kubernetes authentication. There's you talk about like the two entry points. You start from the beginning, right? That there's certificates and bearer tokens, and that's basically the API server. From the API server standpoint, two basic things to check, right? When a request comes up on HTTP, either you have an authorization header, or there's a client cert, like a TLS cert, right? That's the decision. That's the basic decision that the API server has. Does it have any other configuration?
There are definitely
Can it handle both at the same time?
I think if you gave both, TLS would win. I think that that's a guess. But the thing is,
I meant that, like, you can have an API server that will handle if the request comes with bearer tokens, right? Request comes certificate. I think for the most part, it in practice it works with both, because different use cases.
Yes, absolutely.
Yep.
And then you mentioned also that there's no and then maybe this is something that people get tripped up if looking for kubectl get user, kubectl get groups, right? There's no objects, there's no type in the system, right? Like humans, I think the system was not intended for humans, like users, to be added, right?
Right. And except for with the exception of service accounts, which is a little bit different, which we dive into next. But yeah, I mean I think this was a very smart decision, by the way Kubernetes was designed, in not having any internal users, right? By leaving it up to the implementer to figure out. And I got into a lot of discussions around this over the years where people were like, no, Kubernetes should have users. Kubernetes should have users. Like, all right, let's say Kubernetes had users and groups in it, and you store a password or a token or whatever, right? The way a service account does. How do you securely get that to the person? How does the person reset it? What is the user interface for that? Kubernetes has no user interface. It's just an API. So that's a whole lot of additional infrastructure that you would have to put into Kubernetes to make that work, when there are already systems that do it and there are standards that do it. So yeah, I think it was a smart move with the original implementation, not including users and groups and passwords and some kind of enterprise identity system inside of Kubernetes. Better to let someone else handle that.
And you put some tidbits, like a lot of like details, right? That there's something called system authenticated. That's a group that automatically gets assigned to a
Right.
user
Well,
when
it
logging,
actually isn't automatically assigned.
but you later
That's not
you talk
necessarily
about it,
true.
right? That might not be automatically assigned.
Right. So there are system assigned groups. So there are groups that when um, when a authentication occurs, depending on the kind of authentication, will get assigned. So like as an example, service accounts, the only groups that service accounts can be part of are the system assigned groups, like the namespace that they're in. You can't arbitrarily assign a service account to a group, which makes them a little harder to build RBAC bindings around. But it's really dependent on the authentication system, because when we get into impersonation a little later in the chapter, you as the impersonating proxy have to make sure to inject those system assigned groups. Kubernetes doesn't do that for you. That caused me all kinds of pain when I first started working with impersonation.
So you have to put you need to include the system semicolon in the like CN equals in the token. Interesting.
Yeah. So when you
Or
do
injected, I think you
impersonation,
mentioned like it can be injected by the
yeah,
proxy, right? That's the best
right.
practice.
So when you do your impersonation, impersonation is reverse proxy. You put headers in the request that say, this is really who you want the user to be. So you're going to use my token, the proxy's token, but do everything on behalf of this combination of user and groups. And Kubernetes, it's just strings. So it just takes that and creates a user object. So if you don't include system authenticated in those headers, it doesn't get pulled into the user object.
Interesting. And then you start explaining OpenID, and I think you did a great job with this.
Thank you.
Where the access token, and you go and break this down. The access token is not an API server. It's not a Kubernetes thing, right? This is something that you use to get the ID token. Is that correct?
So this is the interesting thing about OpenID Connect. Kubernetes and most people do not use it correctly. The ID token is not meant to be used by anybody but the client. You are not supposed to be passing your ID token around as your identifier. But it's the difference between de facto, what people do, and what the industry has decided to do, and what the way the standards writers envisioned it. So the way that it was supposed to work is I would authenticate to my identity provider, and I'd get all these tokens. And then I'd say, I want an access token for this Kubernetes service. So I'd go back to my identity provider and say, give me an access
and you get
token
three.
for this identity.
You get
service.
access token, ID token, and refresh token.
From your right, IDP. Because potentially the access token is not necessarily is not necessarily a JOT. It's not necessarily a JWT. It can just be opaque value.
I see.
It's just that then means that opaque value has to be validated somehow. And there are in fact draft standards to codify this, but ultimately the way that Kubernetes ended up implementing it was, okay, we really don't care what how you got this JWT. It still doesn't really care, because the thing is, Kubernetes doesn't know anything about OpenID Connect. Kubernetes only understands a JOT, a token,
a header, authorization, and bearer token, and it's a JOT.
Well, just in the case of OIDC. So typically with OIDC, your client knows how to interact with the identity provider. Kubernetes, your API server, has no idea how to interact with your identity provider. That's all done by Kube control.
The logic is Kube control for the refresh, right? To
exactly.
Get the refresh.
But the API server The only interaction it has with the identity provider is to pull in the metadata document, the discovery document, so it can get the public keys to validate signatures. That's it. Kubernetes has no other understanding. It doesn't care how you got that token. It's not really OpenID Connect. It's just, or at least not OpenID Connect from a browser. So by separating out the authentication from the relying party, Kubernetes actually really bastardizes the OpenID Connect protocol. And when you go and you talk to my peers in the authentication world, they all bemoan the fact that this is become the de facto standard, not just with Kubernetes, but with other APIs as well.
Yeah, and that's what you give to the API server here, like the IDP. No, this is for the configure the API server. Is this is the
So this
same
is Kube
for
control.
kubectl?
Yep. So kubectl out of the box knows how to take a existing ID token, an existing refresh token, and refresh it consistently. Now there is a bug, a very well-known bug in Kube control, where if you've got multiple Kube controls running off of the same
You mentioned
Kube
that
configuration file, and they try to refresh and they overlap, they'll blow each other up.
depending on the OpenID server IDP implementation, right?
It's the timing. So what happens is when you do a refresh, and we get into this in a little bit, when you do a refresh, what the spec says is that your refresh token is one-time use only. You can never reuse it. And so what ends up happening is if you have two Kube control, and this is a client Go SDK issue, you've got two Kube controls talking in the same configuration, doing multiple API calls, and you do a refresh, and they don't refresh, and they refresh at about the same time. What happens is process one gets a refresh token, writes it. Process two has the existing refresh token, tries to refresh it, but that refresh token is now invalidated, kills the session, and it kills the Kube control. So it's like Open Unison, we added a feature to get around that where we give you a grace period. You can configure where like a 10-second grace period or something. I see Alan's had his hand up for a while. I want to
go ahead, Alan.
Make sure we're answering questions too.
Hey, Mark. Yeah, it just goes back to your comment on Kubernetes API not truly implementing OIDC the way it was intended in the spec. Has the community discussed a proper way, or does that require some kind of UI, like you mentioned, to properly implement that experience?
I think it's less about Kubernetes having to do something different, and more about folks like myself who build the integration layers, going that extra mile to say, okay, let's configure our services to do that extra step. But honestly, I think the reason why we do it this way is because that extra step doesn't really add a lot of security value. Like, I've asked for an additional token. Like, what does that mean? What does that do for me? And so I think that we're here because that additional step doesn't make sense in the way that Kubernetes uses OIDC. The original design was that the access token is supposed to be opaque. You don't really know, and you're passing it around because it's a bearer token.
Opaque and included, you mean in addition of the ID token, or the ID token wasn't supposed to be 10?
Well, the ID token was never meant to be passed around. The ID token and the refresh token were always meant to stay with the client. The ID token is there so that the client, so in this instance, it would be Kube control, knows who you are and can make decisions. But for actually calling APIs, the access token is what you're supposed to use. And that access token wasn't always designed to be representative of a user. It could be representative of a machine, as an example. And so all you have to do is validate that token is good by going back to your identity provider and say, hey, I got this access token. Is it good? It didn't have to have
good for access, for not identification, could be, right? For accessing, but not necessarily identification.
Right. So, but what from a de facto standpoint, what ended up happening was API designers said, one, going back to the identity provider to get that information validated, that doesn't scale, right? Because now every time you do an API call, you're going back, and that's just jacking up your traffic, and you're not buying anything out of that. So that's the first problem. The second problem is I need to know certain things, right? So what would end up happening is I do an access call, I'd validate that, but then I need to figure out who you are anyway to make
To give you access.
authorization decisions.
What groups do you have? What claims do you have? Do you have a second call?
Exactly. So using an ID token basically became the layer 7 equivalent of a certificate.
Where it has all the
It had
information.
everything you needed to validate it.
And the only thing that the API server needs, and the API server, I don't remember, but it needs a public key, like the public certificate to validate the JOT is valid or not, right? It doesn't have to talk
Not
to a
even the
live
certificate.
system.
Just the public key.
The public key to validate that JOT
No certificate is
good.
needed. Right. So when you look at
the well-known location, right, for a file.
Right. When you look at the key metadata, when you look at the discovery document, there's going to be a URL for the keys. Most of the time, those keys are just raw public keys. They are not certificates. There's no additional metadata like expiration or anything like that. The idea is that you're supposed to be able to be constantly refreshing that and changing it. And because everybody's pointing back to your discovery document, if it fails, they say, okay, well, I'll go back to your discovery document and pull in new keys. And that was a big problem with SAML, was you ended up having, the SAML spec said that you're not supposed to have certificate metadata in it. But because it was such a pain in the butt to keep these connections updated, they ended up doing it that way anyway. So with OIDC, you're not dealing with PKI, you're only dealing with public keys.
And it needs to be an HTTPS, that OIDC issuer URL.
Yes. Yep. You have to have HTTPS because that establishes that's what's used to establish the trust, right? If I publish let's say you're using Open Unison as your identity provider as an example. I publish metadata, OIDC discovery that says, here's the public key. Well, how does Kubernetes know to trust it? Well, it has trusted the certificate that I'm publishing my metadata in. And so that's how you build the chain of trust.
Oh, like client you're connecting with? I don't think you're connecting with client. Like it's
no,
the server
you're not
client.
using client.
I trust. I'm connecting to an endpoint that I trust.
You're exactly.
Yeah, because I don't think I've seen a client to log in to get that. And it's a well-known public, right, that you trusted, that you get it from a trusted. In AWS, I've seen people put it into, they piggyback on S3. And S3, you can make it an HTTPS and then give access to for example, the EKS cluster.
The thing that's really important, though, is that the domains have to line up. You can't publish a OIDC discovery document to an S3 bucket and say your issuer is S3 : / whatever, or even just put a proxy in front of it. The domain in your issuer has to be the same place that you get your discovery document from. Because otherwise somebody could spoof, right, where it breaks the level of trust. So the level of trust is built on top of the HTTPS infrastructure. So if those issuers don't line up, now you're breaking that layer of infrastructure.
I see. I was looking at the docs, the API server docs. And the other thing that is interesting in here is you talk about the service account, right? Using service account. I think for a while, I saw people like just getting the token from a service account, stealing it, like I call it.
Unfortunately.
Never expires, right? Never expires, or it has a 10-year expired. I can never remember.
It depends on how you do it. So pre 124, if you
Yeah, token
created
pre
a service
before.
account, yeah, it would create a secret that had absolutely no
Expiration.
expiration, right?
Okay.
And so the only way you could expire it was by deleting the service account to delete the key and then recreating the service account to generate a new key. So that was the only way to expire it. Starting in 124, they began the migration off of static service account tokens to dynamically generated one using the token request API, which we cover a little bit later in the chapter, and this idea of a projected token. So then pods started getting tokens just for them. And what was important that was twofold. One, it had an expiration. Two, you had the pod, the individual pod's information in it. So not only did the service account expire when not only did the service account expire when the EXP claim happened, but when the pod died, it would no longer, the API server would stop accepting the token,
because
even
the
if
pod,
it hadn't expired yet.
because it needs to come from that pod, or the pod is not
Exactly.
valid, or the pod doesn't exist.
Because the pod doesn't exist anymore. Part of the
That was a check.
authentication process is checking, does the pod that this was issued to still exist? So give you an example, Rancher, once upon a time, they did something where they would fire up a pod to generate a service account key, grab that service account key, and then use it to talk to the API server. And when 124 came out, they're like, yeah, this doesn't work anymore because the pod's gone away.
Yeah.
Yeah.
I think
So,
I remember.
And this is ultimately why service accounts exist to provide identity to things inside the cluster. They don't exist for you to be able to talk to the cluster. They were never intended to do that. It's just, it was easy, so people did it.
Yeah. And yeah, you explain this piece here where if you were to programmatically or need a token, they added this create token command that gives you back
right
a token, but I think it's valid for X amount. I don't think you can pass how long you want it.
Yeah, there's a demo, or there's a default. It used to be 24 hours. Now I think it's 1 hour. They've been getting it smaller and smaller. I will say, I don't think your token should live longer than a minute. I'm crazy like that, but I will die on that hill.
And I think you mentioned that in other forums. I think it's good to explain to folks the 1 minute, because some people might think, oh, that's crazy if I have to log in every 1 minute, or I have to do all these things. Like, your point is there's a refresh, and there's logic. There's a program in memory running, so that program is just refreshing it. Just so you can refresh it 60 seconds, you can refresh it 1 hour. Might as well just, it doesn't consume much CPU. You don't do a disservice to the world, right?
Right.
By doing it 1 minute, right?
The thing to remember about any bearer token, these are called bearer tokens. JOTs are bearer tokens, and the tokens are not bound to anything, right? Like there were attempts in the past to create tokens that were bound to like TLS connections, but they didn't get very far because it doesn't scale. MTLS, there's a reason why MTLS, mutual TLS, works really great in cluster with service meshes and doesn't work well outside of it, is because you need a point-to-point connection, right? You can't survive a reverse proxy with an MTLS connection. And so, but with a bearer token, you go through all the network infrastructure you want. It doesn't matter. Okay. But the problem with that then is, it's like once upon a time, pick your favorite sport, out there. Once upon a time, you used to show up to the stadium, the ticket window, you picked up your ticket, somebody yanked it out of your hand, ran up to the ticket styles, went through the styles, with it, you're screwed, right? There's nothing that bound it to you. Same thing with these bearer tokens. So, the internet is littered with bugs and problems. And, who among us hasn't accidentally checked a token into GitHub? I mean, come on. Like, really,
happens.
we've
Yeah.
all done it. And so there's what was that? Was it a TV show or a movie? 10,000 Ways to Die in the West. There are 10,000 ways to lose a token. Yeah, movie. Yeah. There are 10,000 ways to lose a token. It's so easy to lose a token. You log it by accident, right? There's a bug in some piece of infrastructure. There have been bugs in CNIs.
Or a bug in a ISP box sitting in some corner.
I mean,
and one of the hubs, right?
So the mitigation against that is you have short-lived, and the shortest lived you can reasonably do. I say 1 minute, but it's actually really 3 minutes, because you do an expiration that's 1 minute out, but then you have a not before, usually be 1 to 2 minutes to do block skew. So it's in reality, it's 3 minutes, but really what you're saying is this thing is so short-lived that by the time an attacker gets their hands on it, they might get some data out of it, but they can't use it anymore. Nobody's going to accept it. And that's really the important part.
Only thing I would say is, as always, make sure that your IDP provider, right, can handle it, or your IDP server. It depends on scale that you're running, how many clients, how many are they're connecting, and at the same time, concurrency connections and things like that. But yeah, measure it, and if you can make it shorter, will be more secure. The other section that you touch is and then this is the example. If you have the book, you can go through the commands to set up the kind cluster in Ubuntu, and you leverage the npi.io. I think there's other ones also that are useful for that. And then this is the section where you do the SSH and set it with LDAP. So it is Active Directory inside Open Unison, or is a fake one, or like a pod that you run?
Yeah, so it's a project called Apache Directory Server, and what I did was added the LDAP object classes and attributes to make it look like Active Directory. The first edition of the book, we actually used SAML, because SAML was kind of all the rage. And in order to do that, to make it easier, what we ended up doing was Tremolo's website actually had a SAML identity provider that you could log into and craft your SAML responses however you want it. And it's great for development and testing. But people didn't like the fact that they had to sign up for my website to use it. And I didn't like it either, to be honest. Even though it was free, I understood that. I got it. We wanted to make it easy, but I got what people were saying. So for the second edition, we ended up embedding a Apache directory server, so that way it could all be local, because we didn't want to have to start dealing with, well, we could set up a little mini OIDC in the cluster, but then you still need a data store. And we wanted to try and keep this as slimmed down as possible. So that's why we ended up saying, okay, we're going to embed an Apache directory server into the cluster, so that way, and there's a config map that you can go in there and make changes, and it doesn't reload it in real time, but if you want to muck around with it a little bit.
We added that in the README for that, right, Mark? It's not in the book how to do that, but in the config map, I added, okay, you want to create your own users, just because you want to do your own playing. It's pretty easy to do. It's really nice for that, and it all deploys, like you were saying earlier, Carlos. Everything's one script. I mean, you get a kind cluster with full IDC integration with user accounts, and I don't know, what do you think, Mark? 3 minutes, 4?
I
use it a lot.
It depends on how long it takes for you to pull down images and
True enough,
kick it off.
Interesting. Yeah, this is very useful to have it in a kind cluster and open source to get something up and running that you can play for learning purposes, right?
Yeah, and to Alan's question about set the claims. So Apache DS, you can set the different user attributes. Open Unison for Kubernetes at least hard codes the claims, because Kubernetes only really cares about a couple of claims out of the box. Although I think with 29 that might have changed with the new authenticator framework that they have in place. But other applications that you integrate that are able to use more claims, you can configure Open Unison to do whatever claims that you need.
And the claims are not the groups, right? The claims is one specifying the groups.
Well, a group is a claim. I mean, a
claim.
claim is just OIDC / JWT nomenclature for an attribute.
Okay.
Right. And inside of the JWT, every attribute is a claim. Going back to the fact that I am asserting something. I am claiming that I am a member of these groups. That's where the word claim comes from.
Yeah, I think you have it. You have it here. So yeah, this is set up that gets you OIDC working and all that, and then I think you get to a point that you use the Open Unison UI, and instead of getting the like CLI flags, you just get kubeconfig. Is that correct? And just download the kubeconfig file.
Sort of. So what we do, so the approach that we take in Open Unison is instead of you having to download a configuration, we actually generate a config for you based on the kube control flags. So when, like, you can start to see the export temp equals, what we actually do is we take all of the different components for your configuration, we generate it for you using kube control flags, and then that then generates your kube control configuration. So that way, if you have an existing kube control config, maybe you have to work with multiple servers at the same time, you don't have to worry about, do I need a plugin to merge them or whatever? It all goes into one. The other nice thing is as a operator, you don't have to distribute configuration files to your admins and keep it up to date. It's all set up for you. So I usually work with like a temp director, a temp file, and then run my kube control config. So that way I don't have to worry about cleaning up after myself. It'll clean up on its own.
So basically,
yeah, and I even do that here.
Basically this, but the question is the user doesn't have to go back to the UI to get a new one. Like as long as you run kubectl, often kubectl will be in charge of refreshing that token. Is that correct? And that token gets saved in disk in your home directory?
It gets saved. So it gets saved. We use the standard kube control configuration. We don't use, there's a very popular kube control plugin called Kube OIDC. We don't use that.
Yeah.
So it gets stored directly into your configuration, which is kind of a security no-no. That's why I like to use temp files. So that way I'm not keeping them on disk anywhere. But the thing is once you log out, whether your session times out or you actually hit the logout button, those tokens become useless.
Log out where?
From Open Unison.
UI?
So, yep. So when you log out of Open Unison, your kube control stops working.
Oh, okay. Okay. So the session in the browser, you keep that active.
Yeah.
But so what is that? Can you talk a little bit about that plugin? Because I think we're going to discuss that. I'm going to discuss that next week with Ofer from CTO from Wiz. He's going to talk about that plugin. So, but I'm not familiar with it. Why did you not use it, or you don't need to use it?
Well, we don't really need to use it. The thing with the Kube OIDC plugin is that it does something that Kube Control doesn't do. So Kube Control does not know how to pop open a browser, ask you, to send you to the right URL and authenticate you, right? All Kube Control knows how to do is to take the result of that authentication process and, work with it from there. What the Kube OIDC plugin does is it will say, okay, given knowing where your identity provider is, I'm going to pop open a window or give you a device flow URL, and I'm going to do that. You authenticate, and then I'll go ahead and set my local configuration. So it uses a Kubernetes authentication plugin to be able to do the entire life cycle. Now, the major downside to that approach
And it's
is
generic
that
enough that works with everything. It's
Yeah, it
generic
works
enough that works.
I mean, those parts are standard.
YubiKeys and okay.
Well, because all it's doing is popping open a window and sending you over to a web browser. The major downside to that approach is you need to pre-configure it to know where your identity provider is. So now you have to have a kube control configuration file that you distribute to your clients. With Open Unison's approach, there's no configuration to distribute. You just go to the portal, you pull it in, you're off to work.
And leave the portal open, right? Logging in while you were logging in the portal, it continues
Well,
to work.
so if the portal times out, if the portal session times out, but you continue to use your session, it will keep refreshing. Right. So
okay.
if you
what you meant before was an intentional revocation by the logout.
Right. Or if you are in a situation where, let's say, I had to get walked out the door, right? There was a security incident. I had to get walked out the door. You want to make sure that I can't have access. You can go in, delete all the tokens from my session, and then on the next refresh, this is another good reason to have short refresh tokens, because there's no way to revoke a token. When I go to refresh, it'll fail. So that's another good reason to have short refresh tokens.
What about cloud managed Kubernetes clusters? Are there nuances to handle, like corner cases, or what doesn't work, or what do you think is difficult, or is it the same? Like what's the deal?
So the interesting thing about managed, and I don't necessarily even want to say cloud managed, because like you'll run into this with VMware as an example, where VMware doesn't let you configure OIDC if you want to use an OIDC provider other than Pinniped, the integrated Pinniped. So it's not just cloud managed, but it's really any managed environment can run into this situation. So this is where you get into impersonating proxies. Now, it'll be interesting to see over the course of, I would say, the next 3 to 4 years, where starting in 129, I think it went alpha, you can actually, it's not an authentication webhook, but it's the ability to tell Kubernetes to support multiple token sources, but it's not a object in etcd. It's a file that has to live inside of the API server. Structured authentication. Yes, Alan, thank you. And so what would work fine with like Kube ADM, has to be explicitly supported by EKS, AKS, whatever. Now, everyone I've talked to said, we're going to support it in some fashion. We just don't know how. So that might eliminate the need for impersonating proxies like Kube OIDC proxy. But I think it's going to be a while until that becomes standard practice. The one major issue with impersonation, well, there are a couple of big issues to keep out for. From an operational standpoint, Kube control exec and Kube control copy and port forward still use, I'll caveat this, I'm going to hit a star on this, still use the old speedy protocol, what eventually became HTTP2. It is the only thing in the world, Kubernetes is the only thing of modern architecture that still uses speedy 2, or uses the speedy
onto
protocol.
that version that they added the web.
So that it supports, so it's a two-part problem. It's the support on the server side and the support in the client. On the server side, once there were new SDK, when Kubernetes went live, when Kubernetes went 1.0, Speedy had already been deprecated in browsers.
Oh,
it was dead. And so when new SDKs started coming out for like Python and Java, Speedy didn't exist anymore. There were no client libraries. So they added WebSockets support. So the server has supported WebSockets for a long time, but the client Go SDK, which is what like 90% of the world uses to interact with Kubernetes, doesn't support Speedy until 32 started to support Speedy for exec. I don't think it supports it for port forward. That was a big issue. So like so my company Tremolo, we forked the Kube OIDC proxy from Jetstack was the name of the company, I think, to solve this problem because we're Java based and we couldn't support Speedy. And
yeah, you mentioned that in the book that you forked their OIDC proxy.
Yeah, we originally did that because originally the plan was we were going to add WebSocket support to the client Go SDK, and I actually got it working. And once I got the port forward, it was like way over my head to make this work. And I ended up giving up and said, "Screw it, we'll go with this approach." So, but the side effect of that is that a lot of modern networking infrastructure does not support Speedy. So Envoy does not support Speedy. ALS or AWS application load balancers, anything at layer 7 does not support Speedy. So when you look at how you do your load balancing, like EKS, it's usually not that big of a deal because people tend to use layer 4. But a lot of times, if you've got any kind of layer 7, Speedy won't work. And so that becomes the big issue with impersonation. Although I haven't tested it yet, I do believe with 32, and we just released Kube OIDC proxy 109, I think last weekend. We try and keep the releases synced up with Open Unison. And every time we cut a release, we bump all of our versions. And so I think, I haven't tested it out, but I think with 32, if your client does WebSockets, Kube OIDC proxy will do WebSockets. So that'll help get around that problem as well.
So the reverse proxy, where do you see people running it? Is it running in one location for multiple clusters, or everybody running inside the cluster?
Yeah, I would certainly not do that. That's a real easy way to have problems. Somebody actually forked Kube OIDC proxy from us about a month ago with that exact plan. That's what they wanted to do. It looked like they had some kind of product similar to like an Open Unison or even like a Rancher, some kind of management system. And
but in enterprise, how do they run it? Like, if they want to put it in cloud against cloud managed clusters, where do they have multiples? Like they'll have to run one of these per cluster.
I recommend running it
external.
In cluster. I recommend running it in cluster because when you run it in cluster, you can use a short-lived token. Because the thing is that the token that you use for impersonation should be considered
is the bot one, the service account.
Exactly. And so you want that to be really short-lived. And the shortest lived you can make a token in Kubernetes is 10 minutes. So that's what I would do.
That way it's not between that reverse proxy and the API server is just they're tight, like they're in the
exactly
and
now
and such.
In theory, you could run out of cluster and then use a service account, but that's bad, right? You don't use service accounts from outside the cluster, or you could use MTLS, but that would get kind of complicated, really. So there are ways you could do it. Like in theory, like let's say you had a EKS cluster and you ran the proxy on an EC2 instance.
Yeah.
And you use the EC2 instance's identity.
I am, bro. Okay.
Yeah. I mean, you could do stuff like that, but honestly, it's small. It's lightweight. Run it in cluster. Don't bother running it outside the cluster. You're not gaining anything but heartburn.
But then there's something that you have to do a HTTPS, SSL, and domain name, load balancer, right? To
Yeah.
expose it.
So like what we do with Open Unison.
Because that's the one that you're going to connect to. So it means it could potentially mean that I can have my manage and it gets cluster private. That API is private, and the only thing that is public is the reverse proxy. Because now nothing external in the world is talking to the API server. They're always talking to the reverse proxy.
Yes, that is true.
Okay, that's one way of making it secure, but you're impersonating anyway. But yeah,
Yeah.
okay, so it will
I mean,
work
you're
when
doing,
it's private.
yeah. I mean, I like it because it's just easier to configure. Like, I'll be honest, whenever I configure a cluster, whether I'm on-prem or I'm in the cloud, I always go for like, unless there's an explicit use case where I need to test OIDC, I just reach for impersonation. It's just easier.
So you maintain the latest version now, like you're the overall maintainer
Yeah.
now of the reverse
Yeah. I
proxy?
mean,
And you keep
Venafi
CVEs and those type of things.
Yeah, Venafi abandoned the project in 2020. They abandoned it. We picked it up late 2020, and they kept telling us that they wanted to come back to it. They wanted to come back to it, and then about a year ago, I think they actually archived the project and said, screw it, just go to Tremolo." And so that's that. We now maintain Kube OIDC proxy. We're now its stewards.
I see. And the proxy is compatible with that plugin that you mentioned, the OIDC plugin kubectl, or?
Oh yeah.
Okay.
Absolutely.
Okay. So it's a light way of impersonating, like passing down the identity. Like you have good diagrams here, right? So it's standard headers that the API server knows to parse, right?
Yeah. So these headers are all standard, defined. There is an additional
Standard
header, which I didn't
Kubernetes or
talk about
standard
here.
just in security?
Kubernetes.
It's a standard Kubernetes
Yeah.
headers.
There is an additional one called impersonate UUID, because every user gets a unique ID, a GUID inside of Kubernetes that in theory is what we should really be using for name-based RBAC, but we don't. But it's there for tracking purposes. So you can also impersonate that as well. The issue that you run into with that is not every client does it. Although I think starting with 32, the client Go SDK actually mandates it. Because when we cut the 109 or the 108 release of Kube OIDC proxy, people who were pointed to the latest tag, it broke because their clients weren't sending, or the clients weren't sending the right headers, and so it just broke. And so I told people, look, if you're pointing the latest, you need to go back and make sure you're tagged. You're using a very specific tag.
So where's this UUID for the user stored, and how does both client and server knows about this UUID mapping to
It's
the
ephemeral.
user?
It's like user. It's completely ephemeral. It gets created when the user authenticates. It's something that you will only ever really see in the audit logs. And so that's why I decided not to.
But it's consistent?
It depends. If you as the identity provider provide it, it's consistent. If you as the identity provider don't, then it gets generated by, it's more of a session ID than a user ID.
I see. It's more a session ID.
Yep.
Okay. I think we are out of time. This is an extensive chapter that I knew that we were not going to cover all. But thank you, Mark, for all the details and backstory.
One thing I just want to really point out about this chapter is we we also dive into what not to do in this chapter. We get into anti-patterns in authentication, like certificates, like service accounts, and we do explain why you shouldn't do this.
Yeah.
And then at the end, we talk about pipelines and how you should be authenticating from pipelines and different
CI/CD
ways to do
pipelines
that.
that are like
Yep,
are outside the cluster.
exactly,
Yes.
because that's a big issue. And I've written a ton of blogs, but I've actually got a blog series that I've been doing since late November on using Open Unison as an STS to be able to do authentication into the cluster from GitHub, from GitLab, from different Kubernetes clusters. I want to do one with Spire to show that one off. It's an important topic. It's one that often gets lost in the conversation.
Well, that's a big topic, Marcus. For me, when we started talking years ago, right? Because Carlos, a lot of people just create a service account and say, "Cool, go use it in Jenkins or something." It's like,
Yeah.
okay,
Yeah.
it's a shared account. That's just horrible. So you do something like this. There's an API front end, say on Tremolo. You can grab your token. You can do a AD account at this point. Have all your normal processes. It's not long lived, as per se. So I think that's a huge thing for this. I agree, Mark, on that part. That's a huge thing to call out.
Yeah, so I saw those anti-patterns. The same thing for if you're using I think you mentioned, like, if you're using a cloud provider, use the AIM role. And in things like, for example, GitHub, you can, in a GitHub action, you can like exchange your GitHub
Yep.
identity for an AIM role identity. And then in ECAS, you log in with that AIM role that matches to a
Right.
group, but never grab the service account and put it, because people would say, well, I can grab the service account JOT token or and then just put it in a GitHub secret that I didn't put it in Git. I put it, but it's permanent, right? And
Yeah.
I bet that you copy paste and put that thing somewhere else. And you mentioned like 10 ways of like that secret getting leaked and not rotated, I guess, right? People don't
Yeah,
rotate.
it's and there's been a lot of movement in the last few years. I think GitHub really was the first one to say this is how you should do it. And everybody else has been kind of coming along for the ride. But yeah, I mean, you want to use your native identity as much as possible. So if that native identity is IAM, great. If that native identity is a service account token, exchange the service account token for something else. But and it's also okay to use a service account token for things outside of the cluster, right?
Yeah.
Because you can define a service account, like we did this in the Vault chapter, where you can say, I'm going to define a service account token that is good for Vault, and the API server won't accept it. So it's okay to send that out into the world because you're identifying yourself. It's when you generate a service account token to use from outside of the cluster against the API server, that's bad.
Yeah, and I think so Scott mentioned the canonical example of like will be found in Jenkins, right? People put it in Jenkins to do that. I guess I haven't used Jenkins in a long time, but I guess they can use your practices, even the your CI/CD proxy, right? I think you have an example here
Yep.
that you have a CI/CD proxy that acts like the reverse proxy, or this is just an implementation of the reverse proxy? You just call it
So
CI/CD proxy.
CI/CD proxy is a marketing of the Kube OIDC proxy specific to this use case.
Okay.
So the idea was that it had a specific Helm chart. It had with pre-integration for things like Istio and Nginx and Nginx Plus and traffic. And so the idea you could just deploy the CI/CD proxy and so it's the CI/CD, it's the Kube OIDC proxy. It's just, there you go. It's just in a more specific form. We do this in Open Unison multi-cluster, where when we talk to a remote cluster, we don't talk through We don't talk directly to their API server. We talk through a Kube OIDC proxy so that we can generate short-lived tokens. I believe Rancher does something similar, to be honest. They do something similar, I believe, these days.
It is something that you can deploy by yourself. With
Oh
a
yeah,
chart,
yeah.
it's part of the
This
Open
is
Unison.
completely independent of Open Unison. So the idea here was to create something that was specific to the use case that did not require Open Unison to deploy.
Excellent. I'll add it
Because even though we maintain the Kube OIDC proxy project, we don't maintain any of the Helm charts in the repo. We only maintain the Go binaries. So every Helm chart that's in there gets and they're like Terraform scripts and stuff. That all gets maintained by community members. We accept PRs on that, but we don't, like, if somebody opens up an issue on that, we're like, I'm not helping you. I'm sorry. We're
the deployment aspect, but the binary is the binary,
exactly.
Right?
So like Open Unison, right? So like Open Unison, we embed it in Open Unison. It's just a part of Open Unison. So like if it's not working when you're using it with Open Unison, we'll help out. But if it's not working because you just
so many configurations or a deployment problem,
we're not gonna, we'll do our best, but we'll accept a PR, but we don't maintain any certification of how, it's all without warranty. So this was an attempt to say, okay, for the CI/CD use case, this is how you could do that with something very similar to Open Unison's Helm charts that auto configure the ingress.
Very nifty. I wasn't aware that this existed. So
yeah, I haven't done a good job of promoting it. I'll be honest. This was the idea behind this was an attempt to better monetize the work we put into CI/CD proxy or to Kube OIDC proxy, because there are a lot of folks out there that will use it and not give us money for it. And so we wanted to be able to provide some kind of value add that said, okay, this is how we make it a little bit easier. And something that we could support, but it never really gained a lot of traction. So we still maintain it, but I haven't really found anybody who's like, yeah, we'll pay money for this, unfortunately. So if you find someone that will, come tell them, say hello to me.
yeah, this is nifty, very nifty. I didn't know this part. So yeah, that was the next session. So I'm talking about best practices, anti-patterns, stay away from certificates if you can, temporary tokens, and then for pipelines that are like pipelines or even runbooks, right? SREs have runbooks that and I think you also explained. I really like that you explained this section. I don't know where it is, where in production systems usually people don't have access to the production system. They ask another system to give you access temporarily, and then you use that's where you start with the impersonation. Why would you impersonate an admin or an admin account, or the trouble or the toil of creating so many mapping admin accounts? You go over that of mapping one admin account to a group versus having a impersonation, because it will be embedded who initiated the session. So that'll be in your audit logs and your OIDC log. So you can see I did my homework. I read the whole chapter.
Yeah.
So yeah, this was a good chapter. So as a reference, I would say to folks here, right? Get the book, because if you're doing this type of work, this becomes the book that you go back to as a reference and double check things. So there's no more questions from the folks. We'll see you next week. We'll talk about the next one. It's RBAC and auditing, which is very